Hey everyone, welcome back to our YouTube channel Concepts Decoded. Today we will be starting a new topic called KNN, K nearest neighbors. So let's discuss what is it. KNN relies on the idea that similar data points tend to have similar labels or values. Typically, it is used for classification algorithm. So what happens in KNN? In KNN, an object is classified by a majority vote of its neighbors, with the object being assigned to class most common it among its k nearest neighbors. Here, the value of k affects the algorithm performance and sensitivity to noise in the data. Let's understand it by a simple example. Let's say you have some pictures of animals and you want to group them. KNS is like asking your friends to help you with the grouping of animals by looking at the pictures. So majority of your friends are saying that the particular picture is a dog. So the conclusion will be that the picture is probably of a dog. So KNN is very simple to implement. It is robust to noisy training data and it can be more effective if the training data is large. This was the brief of KNN. So now let's have a look how to write the code for it. So the first step is always to import the necessary Python libraries. Now we will upload our data set. We will copy the path. Now we will print first 5 rows of our data. Now we will split our data into training and test sets, for which we have from sklearn.model selection. Now we will print all the X train. Here we have printed. Now we will print the Y train, print X test, print Y test. Now we will feature scale our dataset, for which we have import sklearn processor. And we will fit transform our X train. Transform the X test for the same data. Now we will print X train and X test. Now we will create the model for KNN, from which we will export from sklearn.neighbors. Initializing a variable classifier number of neighbors we want. So we will give it 5, comma. Metric we will use Minkowski, which is a generalization of both Euclidean and Manhattan distance. So, and p is equals to 2. P is the power parameter for the Minkowski distance. Classifier dot predict. Now we will predict a new result. Print classifier dot predict sc dot transform for 30 and 87,000. 0. Now we will predict the results for test sets, which we will ypred is equals to classifier dot predict test. Now we will be making a confusion matrix. Sklearn dot matrix import confusion matrix and accuracy for cm is equals to confusion y test and y print cm accuracy score y test and y. So we have the confusion matrix here: true positive, true negative, false negative, and the accuracy score as 0.93. Now we will visualize our both training and test sets. So So here we have the training set graph for KNN. Now we will be doing the same to visualize test set, but we will change here the x train to x test and y test. Here we have the test set for the KNN. Now we will be dealing with a new term, which is the accuracy, how to calculate the accuracy of the model. So we will create a function model which will take two arguments. Okay, model, one is x train and next is y train. From sklearn, we will print the accuracy of classifier on training data. So we have the accuracy 0.91. Now we will import the confusion matrix. PP is equals to, so we have calculated the accuracy from the extracted values, that is 0.93. Now we will calculate with the graphical representation using AOC ROC curves. We will import them. Now we will plot our curve. We will have x-axis false positive rate and y-axis as true positive rate. This line will plot the ROC curve, and now we are plotting the diagonal line. So we have to write here the plot 0, 1. We will have a dotted line. Now we are labeling the x-axis, y-axis is true positive rate. Title of the graph is 0 rating characteristic ROC curve. Legend is added to plots to differentiate between classes, and which uses colors in the listed color map. Model is equals to, okay. This will train our model on the training data. Now we will predict the class rating. Now we will compute the ROC AOC score and predicts the probability. Then we will print. So we have the value for the AOC. Now we will compute the ROC curve, which will return us the false positive rate, true positive rate, and threshold values. And here we will plot our ROC curve. Yeah. R and PPR. So here we have the dotted line for the KNN, and we have successfully implemented the code for it. We have visualized our training and test sets. We have, for the first time, checked the accuracy of the model, and we have plotted the curve for it. So subscribe, like, and share the video. Till then, stay curious and keep learning.